Hello students, Dr. Sharma here again. Let's discuss about the interesting problem about vector. Okay, the problem reads: the Chingar stream, that stream lies in Nepal. Okay, that is nearby my village where I born. Chingar stream flows from north to south at a speed of 40 km per hour. Okay, it started from Gurase in the north and it merged into the very river in the south. Okay, that's the real stream. During Dr. Sharma's high school days, he used to cross the river from east, that is the Kauli village, to west, that is the Awalching village, to reach Bhairav High School. To move safely with the current and avoid resistance, he walked at a speed of 10 miles per hour relative to the river bank, making an angle of 10 degrees south of west. Given that 1 mile is 1.609 kilometers and the river is 500 meters wide east west, answer the following. Number 1, what were the component of Dr. Sharma's walking velocity relative to the river bank? Number 2, what was his resultant velocity relative to the ground considering the river's flow? Number 3, what was the direction of his resultant motion? Number 4, how far south, that is downstream, from his intended destination did he land up the opposite bank? Number 5, did Dr. Sharma land within 500 meters of his intended west bank destination? Number 6, how long did it take Dr. Sharma to cross the river? That is the best problem, to deal with the vector problem. Okay, let's delve into this problem. Now let's solve this problem. Okay, what's the given here? Let's begin from what's given. Okay, it's best idea to write down what's given here. So the given is you have the Chingar river velocity. Okay, Chingar stream velocity. Let's say the river velocity. I can say that the river velocity, that is the velocity due to the river Br, that is 40 kilometer per hour. Okay, it is moving to the south. Remember that. Let me draw the direction here. Suppose this is the north, this is the south, this is the east, this is the west. Okay, so you see here the river is flowing from north to south. Here Gurase in the north and the south where it will discharge to the very river, very basin here, you can say. So here Dr. Sharma's speed, Dr. Sharma is crossing the river making 30-degree angle like that way. Okay, making a 30-degree angle. So Dr. Sharma's speed, so the Dr. Sharma's speed or velocity, you can say that, or velocity, you can say that velocity, let's say that is the Vs is equal to 10 mile per hour. If you convert 10 mile per hour to kilometer per hour, you have to multiply by 1.609, which will give 16.09 kilometer per hour. Make sense? So Dr. Sharma is moving like that way because Dr. Sharma's walk at 10 degrees south of west, 10 degrees south of west, actually to cross the river with the current while limiting his downstream drift. With he wanted to cross not far away, but he doesn't want to go anti-current. Okay, he flow with the current so that he can cross the river to go to his high school. So let me write down here the walking angle theta is 10 degree, which is south of west. Look at here, south of west. So here the river's width is given here. Okay, river width, that is east to west, you can say here east to west, that is the width, right? Suppose this is 500 meters. So yeah, it's given 500 meters. Now first question, let's talk about first. What were the component Dr. Sharma's working velocity relative to the river bank? Since his velocity Vs making certain angle theta, so number one, you need to find out the working velocity into component here. Okay, let's do part one. So you have the Sharma's velocities. Sharma's velocity can be can be broken into two components, right? Since he is crossing, making an 10-degree angle southwest, so then it has a two component. You see here, one component is, let me use the another color. If this is his velocity, so one velocity would be in this direction and another velocity would be in this direction. Okay, so let's say that is the velocity of the Sharma along west. So this is the velocity of the Sharma along south. So this Bs has the two component. Okay, it has two component. One Bs west, one is Bs south. Now let's find out the westward. This is the westward. Okay, this is the westward component. Let's say the westward, let me write down the westward, that is x-axis. This one, let me write down here, this one, velocity is Bs west, which is equal to, this Bs is 16.9 kilometer per hour, 16.09 kilometer per hour, and you have to, this component gives the cosine theta. If this is theta, that gives the cosine of 10 degree. Let me use my calculator. If I calculate it, 16.09 kilometer per hour, cosine of 10 degree is 0.9848, which is equal to around 15.85 kilometer per hour. So Dr. Sharma's velocity along the west direction, this direction, is 15.85 kilometer per hour. Okay, so let's find out the Dr. Sharma's velocity component around southward, that is y-axis, this velocity. Okay, so let me write down here the southward, that is the y-axis. So let me write down that is a Bs south. I already defined that terminology here, this one. So this is the sine angle. Okay, this component is the velocity, that is 16.09 kilometer per hour, and you have to multiply by sine of 10 degree, so it gives around 2.79 kilometer per hour. Okay, still you see here the westward velocity is very high than the southward. That's a good thing, otherwise Dr. Sharma will need to cross miles downstream, which is not good for his safety and not good for his purpose. So this is the first problem we solve. So two component of Dr. Sharma's velocity. So westward has this much amount of velocity, 15.85 kilometer per hour, and southward has 2.79 kilometer per hour. But again, this is the Dr. Sharma's own velocity, but we haven't finished the southward even. How to do that? because this is Dr. Sharma's 2.79 kilometer per hour velocity, but the river itself has a southward motion. So you have to add river southward, reverse southward velocity. Okay, because let me write down for your information. Since the river flows south at 40 kilometer per hour, so the Dr. Sharma total southward velocity, because something is pushing in that direction, that is the v net south should be 2.79 plus 40 kilometer per hour, that is 42.79 kilometer per hour. So that's a very important thing you need to be concerned about. Okay, so let me go for another part. So what was his resultant velocity relative to the ground considering river is flow? So how to do that? Direction of the resultant motion. So find net velocity first. Now find net velocity. So Dr. Sharma's net velocity would be here. Okay, let me write down is total velocity vector relative to the ground. Relative to the ground, let me write down the ground here, is you have the one in going this direction, another is going this direction, so resultant would be like that way. So this is the v net, I can say that, which is the this one, this is 15.85, that is the westward square plus southward square, so that is 15.85 square by the Pythagorean theorem, 42.79 square, that is kilometer per hour, so that will give around 2082.1 square root, which is equal to 45.63 kilometer per hour. Okay, that is the number 2 answer. Number 3, what was the direction of his resultant motion? So the angle, number 3 is the angle. So angle theta, south of west, right? We know that. So theta is always equal to tangent inverse of, what is the y component here? Y component is this component, okay? That is equal to 42.79, isn't it? So 42.79 kilometer per hour divided by x component 15.89. So which is, if you do that calculation, you will get around 69.2 degrees. So Dr. Sharma is moving at an angle of 69.2 degree south of west. Fine. So another question are very simple, right? How far the south downstream from his intended destination did he landed on the opposite bank? Another question, let me write down here. So Now use the westward velocity to compute how long it takes to cross 500 meters. So what is the velocity in the westward? Can you tell me? That is 15.85 kilometer per hour. Okay, let's convert that into the meter per second. Let's say, let's make that is 1000, that is 3600. If you do that, you will get 4.4 meter per second. Okay, so the total time it takes, how to find the time? So you have a total distance this much, you have the velocity 4.4 meter per second. Why we converted that into meter per second? Because the the length, the west to east, the length of the river is one shore to another shore is 500 meter. Okay, because that should be now 113.6 second. Almost 2 minutes, right? Dr. Sharma needs to cross that Chinga river almost 2 minutes. There is another question, number 5. So how far Dr. Sharma should drift during that time? So for that you need to use the southward velocity, because the drift comes from southward, right? So here you have to take the velocity along the south, which is equal to 42.79 kilometer per hour. Okay, you get the reverse flow speed plus Dr. Sharma's southward component of velocity. You get that, you got it, 42.79. Convert that into the again meter per second, that is 1000, right? Divide by 3600. So this should be now meter per second. So it would be around 11.88 meter per second. That is the velocity in southward. Then the displacement is, the drift is the displacement you wanted to find, which is equal to speed times how many times it takes, sorry, how many second it takes. 113.6 second it takes, that is meter per second. So you will get 1349 meters. So this is almost 1.5 kilometer. So the final summary, let me write down here. Dr. Sharma's walking angle 10 degrees south of west, resultant motion is 69.2 south of west, and time to cross is around 1.89 minute, that is 113.6 second, and downstream drift is 1349 meters. Okay, the final question is, does Dr. Sharma land within 500 meters? The answer is no. Even with a small 10 degrees south of west angle, he lands 1349 meters downstream, not within 500 meters. Okay, so what do you have to do? Let me ask you another question. Okay, to land within 500 meters, Dr. Sharma should do something, right? What he should do? So to land within 500 meters, Dr. Sharma must walk at an angle even smaller than the 5 degree. Okay, or less south of west. Okay, walk faster westward. So that's how you need to solve this kind of problem. Okay, let me know if you would like to ask any questions during the class. Okay, that's all